Let's go ahead and continue our discussion by talking about Uranus. So, Uranus is the seventh planet from the Sun and orbits at a distance of about 2.9 billion kilometers or 1.8 billion miles. It's the third largest planet in diameter of the solar system, and it's about 4 times wider than Earth. So, we could fit 4 Earths across the equator. It rotates once per 17 hours and orbits the sun once per 84 Earth years. Again, it'll take 84 Earth years to orbit one time around the sun. Okay, this is what we call an ice giant. It is so far out that it's there's a lot of icy materials such as water, methane, and ammonia above a small rocky core. And most of its mass is a hot, dense fluid of these icy materials. The atmosphere is mostly made of molecular hydrogen, atomic helium, and a small amount of methane. Okay. As we can see, it does have a ring system. It's just quite faint when compared to Saturn, but it is visible. And I'll talk about this in a minute. Let's see. Okay, so there's 13 known rings. I should mention that. And the inner rings are narrower and darker, and the outer rings are brightly colored. And you can see this in this fakely colored image here, but you can tell that we have some lighter inner rings and brighter, brightly colored outer rings. Okay. One thing you might notice right off the bat is that the ring looks like it's, horizontal. It's like straight up and down rather than vertical like in Saturn image. That is because this rotates east to west, which is similar to one of our terrestrial planets that we looked at, if you remember, and rotates on its side, which is completely different from all of our other planets. So this guy actually would have like a north and south pole this way, or its axis would be this way. Okay, horizontal. And so when it's rotating about that axis. So it's like a ball rolling along. Okay. It can't support life as we know it. It does have quite a few moons. It has 27 known moons, and hence the fact that I say, or make sure you notice that I say known planets or known moons, because we're still discovering more. So this is still yet to be completely determined and solidified, but these are what are known as of now. Okay. And there has only been one flyby of this planet, and that was Voyager 2. And no spacecraft has orbited it at length to really study the planet close by. Okay. So here's a bit more about Uranus. This is the same image, just a little bit nicer looking. But like I said, we have the pole here. So that would be the pole and the equator there. And so when it's spinning along or rotating about its axis, that's also the motion at which it's moving. Okay. Of course, like I said, which gets very confusing, is that it rotates opposite to what we're used to. So we're used to the sun rising in the east and setting in the west. Here on Uranus, it would rise in the west and set in the east. Okay. So one other thing to note, and this is in your textbook as well, we have some images or a map kind of where the planet will be along its year, so a Uranian year. Um, and so at this time here in 1986, we will have the South Pole going towards the sun and the North Pole pointing away from the sun. Okay. Then, as we move along to 2007, okay, a quarter of a Uranian year after that first one, we have that the North and South Pole are in the, let's see, they're both pointing away from the sun, but we have half of the surface pointing towards the sun. Okay, so in that case here, we'd have half the sunlight at the equator, you could say. So at the equator here, we'd have a full amount of sunlight hitting it. And at the north and south poles, we, let's see, we'll have some sunlight hitting it, right? So we had a full amount of sunlight here and then half here. It's kind of like when we were looking at the moon phases, it's very similar to how much sun they're getting, okay? How much sun is hitting the surface. And so looking at this and continuing on, we can compare that here to our amount of sunlight at the equator, South Pole, and North Pole, and the time, so Earth years. So if we look at this again, here, between here and here, we have a lot in the South Pole. So we'd have here, we would have a lot of sunlight for that first half of the year. And then for the next half, we would have more sunlight in the North Pole and no sunlight in the South Pole. Okay, the equator goes up and down because it gets a little bit of sunlight and then it won't for just a tiny bit of time, but then it will for more time, I guess I should say. Okay, so this will probably take a little bit of getting used to, but it's the same idea when we were looking at moon phases. Okay. All right, so let's talk about our last Jovian planet here, which is Neptune. It's the 8th planet from the Sun and orbits at a distance of about 4.5 billion kilometers or 2.8 billion miles. It is about 4 times wider than Earth, maybe a little bit less. Neptune is just a tad smaller than Uranus, and it rotates once per 16 hours and orbits the sun once per 165 Earth years. So it takes 165 Earth years to make one full orbit around the sun. Again, this is another ice giant. So most of its mass is a hot, dense fluid of icy materials, so water, methane, and ammonia, and has a small rocky core in the middle there. The atmosphere is mostly made of molecular hydrogen, atomic helium, and methane. And so this is the image of Neptune. And these are high clouds in the atmosphere made of methane ice crystals. So here we can see this stripe of these clouds, and that's all made of methane ice crystals. Okay. All right, it does have 14 known moons. Again, hints known. Named after sea gods and nymphs in Greek mythology. Just a tidbit there. It has 5 main rings and 4 more ring arcs, which are clumps of dust and debris likely formed by gravity of a nearby moon. So this is a 2-second, they are 2 images. Both have 591-second exposures, and these are the rings of Neptune. And this was taken by Voyager 2 on August 26, 1989, so quite a long time ago now, but we can clearly see these rings around Neptune. And again, this is something too faint that we would be able to see um, with our backyard telescopes or telescopes here. We would need a very powerful telescope to see this. Um, but they are here, they are present. So all of our um, gaseous planets, all of our Jovian planets do have some sort of ring system. Okay. This is an interesting note that sometimes Pluto, which we are not going to talk about in this lecture, it is sometimes closer to the sun than Neptune because of its elliptical orbit. So Pluto has a very elliptical orbit. They all of them do, but the ellipses are not so elliptical, if that makes sense, or so oval, you can say. Um, so Pluto has such an elliptical orbit that sometimes it's closer to the sun than Neptune. It can't support life as we know it, and I don't think we know enough about its moons to say whether or not they would be able to support life. And Voyager 2, again, Voyager 2 is the only spacecraft to visit, and no spacecraft has orbited it at length. Okay. All right, so I'm going to go ahead and pause here, and then we'll continue with comparing all of these planets.